Okay, so we're going to review for quiz 5 tomorrow. Quiz 5 is going to have the following topics on it. 1.5, and that's because we did not have enough students with good scores, or the average score was not high enough on 1.5. And that's the last page. There's a whole bunch of questions on it on here. It's also going to have on it 2.3, which is those conditional stuff. You know what you have your ISNs. I'm just trying to give you a clue as to what you should look at. 2.3, 2.6, 2.7, and 2.8. Okay, 2.8 was angle proofs. 2.7 was segment proofs and postulates and all that stuff. 2.6 was on the algebraic proofs. 2.3 is on the conditional statements, you know, that inverse, converse, contrapositive. So that's the second time we've done that concept. And 1.5 is going to be the third time that we've taken a quiz with those topics on it. Obviously, they're pretty important. Okay, so the following statement is false. Give a counterexample. This may not be on it, but the concept of a linear pair certainly is. So if it says angle ABC and CBD form a linear pair, then they're congruent, it says here. This is false. What would be a counterexample? And I had people who did this question wrong on the quiz. They drew a pair of congruent angles. You're supposed to do a pair that are not congruent, but are a linear pair, okay? So when you're trying to give a counterexample, you want this part to be true. This needs to be true, and you want this part to be false. The conclusion is the part that you want to be false. That's the counterexample. So if you just give me a linear pair, all you have to do is draw any old line. You can draw a picture. You can just say, okay, they don't have to be equal. This could have been 130, and this one would have been 50 then. This is just an example of a counterexample. Okay? All right, so linear pair they are supplementary angles. Identify the hypothesis and conclusion. The hypothesis is the part after the if. This is on the quiz. It is a if a figure, I actually took and modified some questions from a different worksheet to make your review last night at 6 o'clock. But anyway, I just didn't see that word. I should have removed it. Now it makes more sense, right? If a figure is a rectangle, then it is a quadrilateral. And I thought I took that extra L off of there. Is it still there on your paper? Did I remove it or no? Sorry. It's only the part after the then. So a quadrilateral is one L. That's why that little red thing, it's spelled wrong. All right, enough of those mistakes on that one. I didn't carefully edit it. Okay, so we're going to write the inverse, converse, and contrapositive for this conditional. Okay, let's get a little reminder at the top here. The conditional statement was if P, then Q. The converse was Q, if Q, then P. The inverse, I'm abbreviating, was not P, then not Q. And the contrapositive was not Q, then not P. Okay, so you should, I've said this multiple times. All right, so, all right, so we're going to write the inverse. Well, the first conditional statement is if two angles are vertical, that's the P part. Two angles are vertical, then their measures are equal. That's the Q part. Okay, the hypothesis is the P part. The Q is the conclusion. Now, let's go right to the converse, because this is the order we always did them before. So I'm going to go right to the converse next. The statement, if two angles are vertical and their angle measures are equal, is true, by the way. The converse will be if their measures are equal. Then two angles are vertical. I'm just going to abbreviate the word two with a 2 and then an angle symbol are vertical. Okay, so that would be my converse. To write the inverse, we will negate the hypothesis and the conclusion. So that'll be not P, then not Q. So if two angles are not vertical, then their measures are not equal. I use an equal sign. Okay, so then finally, I need to slow down a sec. Okay. I write kind of fast. All right, so we understand if you can get this down straight, and you can always just jot this down on your paper even, or of course it is in your ISN, right? So look it up and don't mess these up. All right, so it's not that bad. We can now reverse the hypothesis and conclusion and negate it to do the contrapositive. So it's going to be if their measures are not equal, Ariana, go ahead. You want to say, or it's Carolyn. I get Ariana's. Then, okay, if their measures are not equal, then, okay, wait a minute. Yep, then two angles are not vertical. Right. And yet you will be doing exactly this. You will be taking a statement that is your conditional statement, and you will be writing these three things. Okay. And I think I'll try to put them in the order that I prefer them, which is conditional, converse, inverse, contrapositive. Just like I wrote it at the top of the page. Okay, determine whether the statement is always, sometimes, or never true. I don't necessarily have these exact questions, but the concepts could be there within the quiz tomorrow, and we do need to keep on knowing these. If planes R and S intersect at a point T, can two planes, two full flat surfaces, run into each other in just one little point? I hope that doesn't make any sense to you. It's like saying two pieces of paper can crash together in a dot. They can't. It's going to be more than a dot, okay? So this would be never. Okay, like the ceiling and the floor of a house. If they came together in one little dot, it wouldn't hold up. All right, any two lines M and N intersect. If you have two lines, must they intersect? No, but they might. So that's where you get something that would be sometimes. Now this one I had changed on the last quiz. I wrote collinear points R, S, and T. I said collinear. If they're collinear, then how many planes can go through them? Well, tons of planes. You can go any direction you want if they're in a straight line. But this says non-collinear. So if they're non-collinear, then they determine exactly one plane. There's only one way to sit something on those 3 points. It's just like a tripod. You'll be able to stand it up because it will sit on one plane. So this would be always true. It's actually one of our postulates that says if 3 non-collinear points, then you have a plane. It's 2.2, I think. Through any 2 points, there's exactly one line. That's 2.1. I don't like to just remember the numbers. You may just write down what they mean, you know. Well, let's see. Number 5 is 2.2. Yeah, but I'm saying if you don't want to look that up, though, you could just say through, and I'll let you abbreviate, through 3 non-collinear points, there's going to be one plane. That's what it says. So you just telling me what you see here, 3 non-collinear points, then you get a plane. That's what that's about. It is in your ISN though. Bless you. You're welcome. What postulate says that if plane NGH and plane HGM intersect, their intersections align? Yeah, that one is 2.7, but like let's just say, if two planes intersect, then you get a line. The intersection's a line. Then it's a line. I would take that from your wording. And that is 2.7, postulate 2.7, if you want to know. But the reason I don't like memorizing that it's 2.7 is because it's not going to be 2.7 necessarily in another book. All the books don't do the geometry concepts in the exact same order. So when I did this in high school, it wasn't 2.7 probably. It was, I don't know if it was 4.7, you know, or 4.1. It depended on the book and the author. So I'd rather have you know what it says. Now, I'll tell you right now, there is a proof exactly, if very, 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 very similar to this, and it's on the quiz. You must be able to do this and follow the steps, and I think everybody should do well with this kind, because you've been doing this algebra stuff for a long time. We always write the first step, which is y, because we got it given to us. We were given that equation, and we were solving it. Okay, now, how did we go from line 1 to line 2? Good. I'm glad I heard more distribution than multiply, because although we are multiplying 2 through the parentheses, the technical term is to distribute the 2 over the x and the minus 1. So it is the distributive property. Oh, I won't take off if you didn't write property. The next line, what are you doing to get to 8x? We're just simplifying. All right. Now, if you're taking directed studies, how many of you have directed studies TO right now? I know there's got to be quite a few of you. Okay. Your teacher may be using the word substitution in this place. They might. They also may be saying to you simplify or combine like terms is the same thing. I just don't want you to get confused too much, but I much prefer, I've taken out, our book likes to use substitution, which is just not the same type of substitution as I like you to use when it says something like x equals y, and then you have x plus y equals 20, and I tell you, well, you can trade it. That's what I mean for substitution. Emily? You can write combine like terms there, sure. That would be fine. So that's a good answer as well. All right, so I just find that substitution, I want you to know that you're actually making a trade when you do a substitution. So we're going to not use that for simplifying. All right, then we go from x minus 2 equals 30. You guys are probably already done. What did you do on the next line? Well, oh, wait, aren't you adding? Okay, yeah, addition, property. Okay, and then last you went ahead and divided by 8, so division, property. And I'm just being formal writing property. It's actually the division property of equality and the addition property of equality. So anyway, I'm not going to write it all. We won't get that picky. So this next line is what I'm talking about, is that as far as some of the topics will not be just proofs. Knowing your properties. Okay, so identifying this property, the symmetric property says you can flip sides. So if angle H is congruent to angle K, then angle K is congruent to angle H. The reflexive says one thing equals itself, so it would just be another angle POR. Might be something like that. Should do a whole matching of properties or something at some time. We might have like a quick quiz one day and see if we can't match properties and make a few conjectures. All right, here you flip into the other page. So now we're at the part we probably like the least, and this will be on the quiz. Okay, So there's one like this on there. It is a segment proof. You've got some leading things here, so it shouldn't really be all that bad. We know that the first item is simply been given. And then since AB is congruent to segment D, these segments are congruent, then their measures are equal by the definition of congruent segments, excuse me. So then they went ahead and wrote down the next thing that was given. Okay. And then if you can't get this next line, I'm feeling really bad that you're not really even thinking at all. Isn't the answer the same as this line right here? Okay, come on. Answer's written already. Definition of congruent segs. And we did it like that, so I don't mind if you want to do the symbol. If you want to write out the words, that's just fine as well. Okay, now, it says addition property. Well, let me explain what they did because I want you to understand how the proof is flowing here in case this isn't provided. So what they did was they took the fact that AB equals DE and BC equals EF. And they just added BC to the AB and the EF to the DE, which is adding on something that's already equal. Okay, so that's why it's addition property of equality. Okay, next they're writing a whole new line that has nothing to do with these. Really. Except that, well, where do I get this from then? You see this AB, BC equals AC, first and last. And then here, DE, EF equals DF. Look at the picture up here. All they're saying is that AB plus BC equals the whole thing, AC. And down here, they're going DE plus EF equals DF. So what have they done? They're adding up what? Segments, right? Which is your segment. You add two segments to get a bigger segment. Is your segment addition postulate. Okay, you're going to have to know that one, guys. And the one we did yesterday, we were using angle addition postulate. Add two angles to get a bigger angle. So this is add two segments to get a bigger segment. Add another two segments to get a bigger segment. And then, because we already stated that AB plus BC is equal to DE plus EF, and we have AB plus BC there, and DE plus EF right here, you can say AC by trading it right there, and trading this right there. You can make a whole new statement that says AC equals DF by making a substitution. That's where that came from. Okay? If I didn't have the word substitution here, could you have filled in substitution? You gotta, that's something I would expect to be able to do. Okay, so right here, you see, just see the matching thing here and here? All they did was trade AC in there, DF in there for this, and it makes you a new statement. So they're taking these two to make that one. That's oftentimes what's going on in a proof if you're not sure. All right, and then finally, if the measures are equal, then the segments are congruent by definition of congruent segs. Okay, anybody still need this? All right, there's one like that. Hopefully you'll get through at least most of it. Then the other types of questions, this is stuff on 2.8 right here, which we're asking you to find the measure of the numbered angle. I'm also going to be asking you what theorems you used. So if you see a right angle here, then this one's a right angle. Okay. I'm not going to worry about you telling me that if two angles form a linear pair, and one's a right angle, the other one's a right angle. So what I would expect you to tell me is 5 and 6 add up to what, though? What? By the complement theorem? Complement theorem, I let you write complement COMP or COMPL. The complement theorem says those two angles add up to 90. Okay, because they form a right angle. So if you know that, then just do 90 minus 72 and go grab your angle 5. Okay, you'll have some questions along these lines. Matter of fact, I think I just changed the numbers. All right, going for this one. Angle 13 and 14 form a linear pair. A linear pair implies that they are supplementary by the supplements theorem. Okay, so the supplement theorem says these angles will, oh, I don't know why I put that right. Yeah, linear pair implies we got supplementary angles, okay, by the supplement theorem. Oh no, I put it up here. Okay, so then I'm going to go and I'm going to add these guys up. So since the measure of angle, you don't have to write this step, but I'm going to write it. The measure of angle 13 plus the measure of angle 14 is 180 degrees. We trade in, make a substitution for measure of angle 13. See what I mean by substitution? I'm trading this into here. Plus, this one's 2x plus 14 is 2x plus 11. I substitute those in, I simplify. Okay, and then I subtract 12, and I get 12x equals 168. And finally, I divide by 12 on both sides, and I get x is 14. Now, you guys have a calculator. You could have done that. This was the steps I did. First, I combined my like terms. That's how I got to here. And I subtracted. I just didn't show all those details. Most of our proofs were not showing all those steps in there anymore. And we're getting to be pretty good at solving equations. We got 14 for x, and then it says to find the measure of angle 13 and 14. So 13, we're going to do 10 times 14 plus 1. That's 141 degrees. And then we'll do 2 times 14 plus 11 to get angle 14. Yep. You have a meet, or right? Good luck. Okay. The measure, oh, a lot of people miss this. This will definitely be on the quiz. What kind of angles are these? What do you know about vertical angles? I had kids adding them up to 180. So why would you do that? I think it's randomly just saying, well, I'll just take a wild guess because I don't know. I'll just add it up to 180. You know, it seems like a lot of people do that because we've had a lot of 180 stuff. There's no reason for that here. These guys are both acute. As a matter of fact, they're the same little size, so they're equal. So by the vertical angles theorem, we write vertical angles are congruent. Okay, they are not supplementary. We've got 9x minus 50 is equal to 2x minus 1. So I start doing my algebra. I have x's on both sides, so I need to get them on one side. So I subtract 2x. And then I have 7 times x minus 50 is equal to negative 1. Careful. And then I'll add 50. And that gives me 7 times x is 49. And then I divide by 7, and finally I have my answer for x. It's 7. Okay, then next I plug in and find the measure of angle 2. It's 2 times 7 minus 1. And that's only 13 degrees. Not very big. Okay, you will also have some questions like the following. Notice there weren't any angle proofs on here. I told you I'm not having an angle proof on it. Assume that each statement below is the beginning of a new proof. What information could you conclude from it? All right, so what I want you to do is tell me, if you read, Bryce, if you read that angle 1 and angle 7 form a linear pair, what could you conclude from that? And Darylyn, you've answered enough times because you're always focused, and I appreciate that. Bryce, what's this mean? What does it mean to be a linear pair? So I'm looking for something that you can say because you have a linear pair. So I'll let you talk for now, but I think you maybe need to pay attention a little bit better right now, please. Kylie? They're supplementary. Yep. Angle 1 and angle 7 are supplementary. Okay, now, why? What theorem or what thing told us if you have a linear pair, then your angles are supplementary? Okay, they definitely do add up to 180. But I was looking for, there was one of these things that said linear pair. If you have a linear pair, then the angles are supplementary. It was a theorem. I've said it like a whole bunch of times. Yep. What were we going to say? Say it. Which? Supplement theorem. Supplement theorem. Supplement theorem is the answer. Now, the supplement theorem says if you have a linear pair, guys, then the angles are supplementary. That's exactly what it says. So I would want to see supplement theorem. You're going to need to know that. It's in your ISN. Okay, you can look it up. Now, yesterday, there's a couple of things we can write for 15. Yesterday, we talked about something that would be really straightforward. Angle 8 is a right angle, and angle 9 is a right angle. I need a conclusion from this. Cadence? I thought you had your hand going up. Okay. Okay, now, if they're both, but that wouldn't be like the first thing you would say probably because you haven't said anything about any numbers yet. Do you know what I'm saying? So you are right that they would be both. So let's go with like a little before that step, in a sense. If you're just told that they're right angles, guys, what would be the simplest thing to say? There's two really simple things you could say. Chloe? They both equal 90. Okay, so you could say that the measure of angle 8 is 90 and the measure of angle 9 is 90. Now that would be because that's the definition of a right angle, okay? You see where I'm headed? Something just really simple. It's not saying exactly what it says, okay? I think we could come up with one more. Let me tell you where I was headed. Kylie? Angle 8's congruent to angle 9? Yep. And that would have been what we talked about yesterday because we said all right angles are congruent. That was the right angle congruence theorem. Now, I don't care if you write the right angle congruence theorem, but if you just write all right angles are congruent, yeah, that would have been another one. That's the other simple one I was thinking of heading towards. Okay, so good job. Either one of these. This is just another one. Well, I would want one of those, though. That's what I would have been hoping for. Now, Cadence, when you mentioned that they would be supplementary, that would be like something you could come up with now after this. You could like go, okay, angle 8 and angle 9 are supplementary because they add up to 180. You could say, you could go on with it and do more stuff. Okay? But I'm just looking for something simple, a simple, what did we call it before? We said we are coming up with a simple conjecture. That was the word, conjecture. All right, let's go to the third attempt on 1-5. I got to get you going on some of these concepts. Too many of you did not know what that meant at all. Ray BD is perpendicular, this symbol. Okay, I don't know how to make it more clear, but to tell you this. You see the symbol? What are these angles right here just on the symbol? That's what it does. Perpendicular is the word. You need to know it. You've got to learn your vocab. Perpendicular means forms right angles. You have to know this tomorrow. Okay, so when you see that symbol, it means ray BD. And ray BD is over here. It goes from B through D. It's perpendicular to ray BF, which means this is a right angle. Okay, now, it says that EBF, angle EBF is here. Some people don't really know what an angle is yet. It's this inside here. It's the opening. It's how open it is from there to there. Okay, there's your BDF. And then it says DBE, and that's here, is X. Okay, so I'm going to put 3X plus 10 would be in there, and an X would be in there if you were thinking about it. So if those angles are X and 3X plus 10, what do? They add up to, all right, that's your equation. So 3X plus 10, and you don't have to do all this drawing and coloring to figure that out, but some people it helps for visual aid right now. 3X plus 10 plus X, and then I had people who added on an X when it wasn't there, okay? You got to have two angles. All right, so let's go 3X plus X, 4X plus 10 equals 90. Subtract 10 and keep going, guys. We should be getting X is 20. Okay, I probably don't have one quite as hard as the next one on the quiz, but I do think we should go over something like it. This picture is being used again, and since I colored all over mine, I'm going to draw it over right here so I can show you what I'm talking about on this next question. I've got a ray BF coming out here. Got ray going that way with an E on it. Okay. All I did was copy the diagram. So why I did that is because I want to look at where angle ABF is. Do I need to wait a second while you copy that? I think it would be helpful for you to have the picture for studying, but. Okay, angle ABF is, my highlighter wants to be mean, goes from here through B to F. Okay, that's that angle. All the way to there, including all the stuff inside here. Just keeps getting wider as the rays go out. It's not changing its measure by having the rays extend. You can keep drawing that forever. All right, it says that that angle is 4 times the measure of angle FBC increased by 10. Okay, now what I meant by that wording, which I'm going to have a little bit less awkward wording on the quiz, I mean that FBC, we're going to have to let be something. You've got to pick a letter. So what do we usually use? X. All right, so what angle should be X? What angle should we make be X? Well, let's see where this one is. Okay, so I'm going to highlight it. FBC is over here. Up and put together, what do we got? That's this angle. Okay, that's just that whole opening there. It's the little one, and then together they make a linear pair. So this would be a linear pair. And so we're going to write that by the supplements theorem again. We know they're going to add up to 180. So the measure of angle ABF plus the measure of angle FBC is going to equal 180. All right, now we're going to plug stuff in. So first we got to understand what it says. It says, I got to let one of them be X. So pick one, please. It's got to be the little one, doesn't it? It's got to be the FBC because the ABF is 4 times it and increased by 10. We're going to let this be X. And what I meant was that this one's going to be 4X plus 10, that whole big one. So we got 4X plus 10 for the big one, plus the little one, we're making be X, FBC, and that equals a total of 180. So then we add our X's, we get 5X plus 10 is 180. We subtract 10 from both sides by the subtraction property of equality. We then have 5 times x is 160. What is x, please? Did I do it right? Oh, 34? Thank you. Okay, now that's one of the angles. Which one? That's your FBC. So the measure of angle FBC turned out to be 34 degrees. Oops, I forgot the C. Yes, Chloe? I didn't subtract right. Thank you. Is that what you were going to say to me? Hello. Where did I get 160? It's been a long day. I think I'm just tired and spacing. Excuse me. What's 170 divided by 5? Oh, it's 34. So I actually have the right x, but I had the wrong number right there. So please just correct that part. It is 34. You guys already figured it out. Okay, so let's go with now measure of angle ABF. We got to figure out, and it's going to be 3 times 34 plus 10, which you could have figured it out by just doing 180 minus 34. Does it come out to 146? Okay. Okay. We have just a little ways to go. We got this diagram. I had something very similar on a quiz before. I did ask you on the last quiz, on one of them I said give me 2 acute vertical angles, and another quiz I said give me 2 obtuse. So acute means less than 90. You see this box over on the right side? It means angle FKJ is 90. So FKG is acute. So I'm going to use this angle. Oops, I don't want to color it that big. I want vertical and acute. So I'm just going to make a dot here. And a dot over here, because those are across from each other. Kind of starts to make a face almost. So that's angle EKH. And angle FKG. Those are acute and vertical. The next question says, give me 2 obtuse vertical. So someone want to tell me? They just got to be fat angles, bigger than 90. Wouldn't it be the ones up there and there? Okay, EKF. You got to use a K in the middle for all these angles. EKF and HKG. Good. All right. Now I want a linear pair. I'm really tired of hearing myself. Someone give me a linear pair? I don't care what pair you give me. Will you try it? Okay, HKF is a whole straight line. So it's already 180. So when I want a linear pair, I want 2 angles that make HKF. 2 angles that make that line would be great. Right? I didn't mean to stop you, but we could still do it, Gwen, if you want to. Okay, go ahead, Bryce. Say it again, honey. GKJ is too tiny to make a linear pair. So what I want is, okay, you see if you take GJK and you put it together with this one, that would make 2 complementary angles. Yeah, he said JKG, right? Did you say GKJ? What would you put it with? No, we're learning something here, so hold on. You said this one, right? Right, Bryce? Okay, now what are you saying he's putting it with? Nice. Okay, that would work. Is that what you're going to go with? Oh my gosh, good job. Okay, I really was expecting that My bad. I should let you finish, okay? So this is not wrong. There's a whole bunch of pairs in this picture. So this is actually the hardest pair, I thought, for someone to pick out, okay? So he's not wrong. GKJ, gotta say it, he said GKJ and JKE. So you'd have to go all the way to there to get it, okay? JKE. Now, does somebody have a different pair? Okay, I thought these two would be easier maybe, or those two or something. I just didn't really, very nice that you went with the one I hadn't done yet today. All right, didn't quite finish every question. I am going to continue it though after you guys leave so that everybody that needs to look at it will be able to get all of the answers. Somehow I went much slower seventh period when I recorded than I did in my other two classes. Hopefully I didn't go too fast for them. But anyway, we had just discussed that this would be a linear pair, so we named that one and this one. I really thought that most of my students would have gone for probably a little bit easier to look at pair. This was a great answer, but you could have done angle HKE, and this is just another example of a linear pair, and HKE and EKF. And there's actually more answers than that. So as long as you guys have two angles that form linear pair, we'll be good. Two acute adjacent angles, I need two little ones, so I'm going to have to pick these two or these two. Wait, no, this one's a right angle, so I can't use HKJ because it would be a right angle actually. So I have to use JKG and angle GKF. And remember, the reversing of the letters is fine, but you have to have K in the middle. Okay, name one complementary angle to angle F. KG complementary would have to be the GKJ or JKG. Makes the right angle. Complementary add to 90. Supplementary adds to 180. So if I want one supplementary to FKG, I can go this way and do EKF. Or I could go the other way and do GKH. I'm recording. I have a couple more. Find the measures of the angle and its complement if one angle measures 24 degrees more than the other. Okay, this concept has been tough. Complementary angles do add up to 90, so I do have a diagram here to give us a hint. You need to know it's two angles whose sum is 90. So if one angle measures 24 more than the other, we're going to have to let one of them be x and the other be x plus 24. So I would just probably put an x there and x plus 24. And then we know that they add up to 90. So we're going to have 2 times x plus 24 equals 90. We would subtract 24 from both sides, leaving us with 2 times x is 66, and then divide by 2 to get x to be is 33. It says find the measures of an angle and its complement. Well, one of the angles then is 33 degrees, and the other is 90 minus 33, or 57. What kind of angles are 3 and 4 in this diagram? We've got to know that these are called vertical angles. They don't have to go up and down. They can go side to side. And if angle 3 is 6x plus 10, and angle 4 is 3x plus 40, we need to know that vertical angles are congruent by the vertical angles theorem. That allows us to say they are congruent. Angle 3 is congruent to angle 4. So then I solve by subtracting 3x from both sides. That will leave me with 3 times x plus 10 is equal to 40. And then subtract 10 from both sides. And I have x, 3 times x is equal to 30. We divide by 3 and x is 10. So if I want to find the measure of the angles, I would plug back in 6 times 10 plus 10, and both of them are going to be 70 degrees each. because they're equal. If you plugged in 10 in here too, you get 30 plus 40, and so that would be the same answer, 70 degrees. Study for your quiz, look through your ISN, review your vocab. If you need to make flashcards to study your vocab, do it. Got to do something about not knowing the vocab, if that's you. Have a nice evening. Timer, time out.